So sometimes when we're working with difficult problems, we have to realize that basically all the exponent rules that we've been working with also apply to fractional exponents. So for 5 to the 3/5 times 5 to the 7/5, we're just going to basically add our exponents because that's what we used to do before. Anytime we had two multiplied exponents where the bases were the same. So we have 3/5 plus 7/5. In this case, once you do that, all you're going to do is add your numerators and leave the denominators in the exponent. And we get 5 to the 10 over 5, which simplifies to 5 to the 2, which ends up being 25. So that's example 1. Here's example 2. We'll do power of a power. Now we have 8 to the 4 over 3. What you can do is you can take the 8 and change it to a base of 2. And we're going to use 2 cubed for our replacement. So now we're going to get 4 over 3. When we compute, we're going to have to do power of a power between 3 and 4. 3 and 4 over 3. So basically, 3 times 4 over 3 is the same as saying 3 over 1 times 4 over 3. And that gives us 12 over 3. So now we end up with 3 to the 4 as our answer, because 12 divided by 3 gives 4, and we end up with 81. Another set of difficult problems deals with solving using change of base. So we'll do an easy one to start. All the easy ones you were able to do before, but this time what we're going to do is we're going to take a look at the following. For example 3, we have a base 2 raised to the 5x minus 4, and we have 256. In order to use change of base, we have to make sure that both sides have base 2. So we have 2 to the 5x minus 4 is equal to, well, 256 as base 2 would be 2 to the 8. Now, normally if there was any power of a powers that we would use, that we would have to do, we do that first, and then we get to this stage. Now that we get to this stage, what we're going to do is we're going to drop the base. So now we get 5x minus 4 is equal to 8. The next thing that we're going to do is we're going to move our 4 to the other side. So now we have 5x is equal to 8 plus 4, which is 12. So 5x is 12. Now, remember, this means 5 times x. So technically, in order to move it to the other side, we have to divide both sides by 5. And we end up with x is equal to 12 over 5. And we're done. For the next problem, we have a unique situation. We have a fraction as our left side. So we have 2 to the 3x minus 1 is equal to 1 over 32 to the x. The key idea is to undo what we have done. Okay, so before, in order to go from here to here, we originally had 32 to the negative x. That's what we had originally. So what we're going to do is we're going to undo that in the next line. So that is just 32 to the negative x is equal to 2 to the 3x minus 1. Now, we're going to use base 2 because of this side of our equation is already using base 2, so we're going to make this side look like base 2 as well. So 32 is the same as 2 to the 5, all raised to the negative x. And we still have 2 to the 3x minus 1. Now, For 2 to the 3x minus 1, that's already done. But on the right side of our equation, we have a power of a power. So now we must multiply our two values. So we get 2 to the negative 5x is equal to 2 to the 3x minus 1. So we end up with negative 5x, and we have 3x minus 1. Now, we're going to move the 1 to this side, and we're going to take the negative 5x and move it to the other side. So now, we end up with the following. Well, 3x plus 5x is equal to 1. 3x and 5x is 8x. 8x is equal to 1, and now we divide both sides by 8, and we're left with x is equal to 1 over 8. And we're done. So these are some typical problems that we tend to have on our tests. Good luck tomorrow, guys.